Miscellaneous exercise. State Newton's first law. Why are the passengers standing on a moving bus thrust forward when brakes are suddenly applied? A passenger is seated in a bus at rest. If the bus starts to move without his knowledge, why is he pushed backwards? What is the benefit of wearing seat belts when traveling in vehicles? So students, now already you have answered the questions. Let us discuss and see whether you have written everything necessary. So the first question, state Newton's first law. What does the Newton's first law says? Until an unbalanced force is applied, an object at rest remains stationary and a moving object moves with constant velocity. So here students, you have to make sure that you write the correct words, including all the required points of the law. So that means you can't just change it and write it in your own words. You have to give the correct law. So I will write that down. Newton's first law. Until an unbalanced force is applied, object at rest will remain stationary and a moving object, or you can say motion, object at motion, a moving object will move with constant velocity. So, until an unbalanced force is applied, object at rest will remain stationary and a moving object will move with constant velocity. Or here, instead of saying a moving object, you can say an object at motion. Why are the passengers standing on a moving bus thrust forward when brakes are suddenly applied? So here passengers are standing on a moving bus and they get thrust forward when brakes are suddenly applied. We have discussed this example before. When the bus is moving, the passenger who is standing on the footboard is also moving with the bus. When brakes are applied suddenly, the bus stops. So the lower part of the body that is in contact with the footboard stops with the bus. But the upper part of the body is still in motion. It is still moving forward. Therefore, the passenger gets thrust forward. That is the explanation you have to write here. So, I will write the answer. The passenger is moving with the bus when brakes are applied suddenly. The bus stops. The lower part of the passenger's body in contact with the footboard stops. But the upper part, the body is still moving forward. Therefore, we can say passenger is thrust forward. So this is the complete explanation for this question. Now we will move on to the next question. A passenger is seated in a bus. Now this is another instance. The passenger is seated in a bus. If the bus starts to move without his knowledge, the bus starts to move without his knowledge, why is he pushed backwards? So this is an opposite action of what we saw before. Here the bus is at rest, the passenger is sitting, and when the bus starts to move, he is pushed backwards. Why? Initially, the bus and the passenger were at rest. There was no unbalanced force. And when the bus starts to move, there is an unbalanced force. Again, the passenger along with the seat starts to move. So, there the lower part of the body where he is sitting on the seat, so the lower part of the body moves forward with the bus, but the upper part of the body is still at rest. So, therefore, the passenger gets pushed backwards. So, that is what we have to write. When the bus starts to move, the lower part of the body moves with the bus. But the upper part of the body is at rest because there is no unbalanced force, and the passenger is pushed backwards. So students, we have already discussed this example and you understood what happened. I hope you have written the correct answer, including all the necessary points. Next question. What is the benefit of wearing seat belts when traveling in vehicles? So when we wear the seat belt, as we discussed in the previous question, when there is a sudden brake, if you are not holding on to something, even if you are holding on to something, you still tend to move forward. But if you are wearing a seat belt, the seat belt holds the upper part of the body together with the seat, so that the passenger is not pushed forward when there is a brake applied. So the advantage is the passenger will not fall forward or will not be pushed forward when there is a sudden brake applied. That is the benefit. So seat belt prevents the passenger from falling forward when brakes are applied suddenly. That is one benefit. If you can remember, students, we discussed another benefit of wearing seat belts. What was that? Yes, when the car meets with an accident, the seat belt prevents the driver or the passenger from being thrown out of the vehicle. So that is also another benefit. I will include that as well. During an accident, the seat belt prevents the passenger being thrown out. So if it is a very small accident, if the passenger is held with the seat, then there is very less damage to the person. So those two are the advantages or benefits of wearing seat belt. When they ask you a question like this, you can just write the first one because that is always true. This is only when there is an accident. So depending on the question, you might sometimes have to write the second benefit. But always you can write the first benefit. We'll go on to the next question. State Newton's second law. So now we first finished the Newton's first law of motion. Now the second law. What is the second law? The acceleration of an object is directly proportional to the unbalanced force acting on it and is inversely proportional to the mass of the object. So from that only we get the equation F equals ma. So here when they ask you state the Newton's second law, you have to write it in words. You can't write the equation. So here we can say acceleration of an object is directly proportional to the unbalanced force acting on it and is inversely proportional to the mass of the object. So when they say state the law, you have to write the complete law. And as I mentioned before, you have to give the correct wording so that the law is explained completely. The mass of a body is 12 kilogram. What is the resulting acceleration if a force of 6 Newton is applied on it in the direction of the motion? So that means there is an object that is moving and we apply an unbalanced force on the moving object. So you know, if the directions are the same, the object will accelerate. And what is the law that we have to apply here? Yes, students, we have to use the Newton's second law. And you all know the equation F equals ma. So here this is going to be a direct substitution, but only thing, since we need to find acceleration, we have to rearrange the equation. So acceleration equals force divided by mass. Force is given to you 6 Newton and the mass is given to you as 12 kilogram. So if we calculate 6 divided by 12, you all know it's half. That is 0.5 and you have to write the unit meters per second square. That is the resulting acceleration, 0.5 meters per second square. So I hope you got the question correct. We'll move on to the next question. Fill in the blanks of the table given below. We have already filled the table like this when we discussed Newton's second law of motion. So you know what you have to do. You have to use the equation F equals ma. So for all the calculations, we will be using F equals ma. In the first one, we need to find the force. So if I apply the equation, F is equal to m is 10 kilograms and acceleration is 2. So that is going to be 20 Newton. I will write that value here, 20 Newton. Then the second one, force is given to you, mass is given to you. You have to find acceleration. So here acceleration is force divided by mass. So force is 60 Newton and the mass is 12 kilograms. If we look at the two values, 60 divided by 12, it is equal to 5. So it will be 5 meters per second square. So here I will write it as 5 meters per second square. Third one, the force is 4 Newton, but here you can see the unit is grams. Mass is 500 grams. And always remember, you have to have the standard units. Mass is in kilograms, acceleration meters per second, then you will get the force as newtons. So here to calculate the acceleration, the same equation, but we have to divide the mass. So 4 Newton divided by 500 divided by 1000. So you get the unit there as kilogram. Then if we rewrite this, it will be 4 into 1000 divided by 500. Here if we simplify, 5 and 10 becomes 2. So it's going to be 8 meters per second square. So here the value will be 8 meters per second square. And the last one, force is given to you, acceleration is given to you. We need to find mass. The same equation, but we rearrange to find the mass. So it's going to be force divided by acceleration. Why? From F equals ma, to find m, we need to divide force by acceleration. So here force is given to you as 40 Newton and the acceleration is 5 meters per second square. So when we divide 40 by 5, we get the value 8 and the unit will be in kilograms. Why? When F is newtons and A is meters per second, mass will be kilograms. So the answer here will be 8 kilogram. So now we have filled the table. I am sure you had done it before me and you got all the answers correct. Let us move on to the next question. State Newton's third law. Give 3 instances where Newton's third law is applied. What are the factors affecting the momentum of an object? I will answer the questions one by one. So I am sure you have already answered the questions. Make sure that you write it down so you learn the way of answering questions. First one, state Newton's third law. A very simple law. Every action has equal but opposite reaction. Or you can say every action has a reaction of the same magnitude but in the opposite direction. So I will write that down. Every action has equal and opposite reaction. Give 3 instances where Newton's third law is applied. You all have many examples related to Newton's third law. We have discussed a few: rowing a boat, swimming. We even did 2 activities related to the balloon. In addition to that, you can think of a catapult. You pull it back and release it, the stone moves forward. A swing, you go back, you give a thrust and then you automatically move forward. A jet or a spacecraft, because of the burning fire, there is a force acting downwards and the jet moves upwards. So likewise, we can give many examples for Newton's third law. So give 3 instances where Newton's third law is applied. Here I will write down 3 examples. First one, rowing a boat. Here of course students, you don't have to give an explanation. You just need to write the example only. Rowing a boat. then we can say swimming. We also know that when we shoot a rifle, when the bullet moves forward, the rifle moves backwards. So that also can be given as an example. So when a bullet is fired, the gun moves backward. So students, these are just 3 examples. You can write any example that is relevant to Newton's third law. Now we will get on to the next question. What are the factors affecting the momentum of an object? You all are very familiar with the equation for momentum. Momentum equals mass into velocity. So the factors that affect momentum are mass and velocity. And you all know what momentum is. The difficulty in stopping a moving object. So here they have asked you to write the factors affecting momentum. So you just need to write as mass and velocity. You don't have to give any other additional explanation, or you don't have to write the equation. Only the factors. Now we will move on to the next question. What is the momentum of an object of mass 10 kilogram moving at a velocity of 4 meters per second? So here they have given you the values. You have to find the momentum. You can write the equation in words, or you can write the equation using symbols. So we'll write it using the symbols. Momentum P is equal to mass into velocity. So both the values are given to us and in the correct unit. Those are the things that you have to check. Mass is in kilograms, so 10 kilograms, and velocity 4 meters per second. So when we multiply 10 into 4, 40 kilogram meter per second. That is the unit of momentum. And always remember students, when you do calculations, you have to write the answer with the unit. So for you all to remember that and to check whether you have done the correct calculation, it is always easier to substitute the values with the unit. We will move on to the next question. The mass of an object is 750 grams. So here the mass is given to you 750 grams. At a certain instant, its velocity is 8 meters per second. So the mass is given to you and the velocity is given to you. What is the momentum at this instant? So here you can see the mass is 750 grams. If you like, you can convert the unit initially and then substitute the value, or else you can substitute and convert it to kilograms. So we will first do this way. Mass will be equal to this divided by 1000. So that is 0.75 kilogram. Then if we use the equation for momentum, P equals mass into velocity. So 0.75 kilogram into velocity is given to you as 8 meters per second. So if we multiply that, 6 kilogram meter second minus 1. 7.75 into 8. So that is 6 kilogram meter per second. Or else we can directly, or you can do it as P equals mv, and here 750 divided by 1000 kilogram into velocity 8 meters per second. Either way, you will get the same answer. So here also, when we divide 750 by 1000, we get the value as 0.75 into 8. So that is going to be 6 kilogram meters per second. So both methods are correct, but you have to make sure that we have the kilogram unit. And usually velocity is given in meters per second, but you all have to make sure that the units are correct. With that, students, we'll go on to the next question. At a certain instant, the momentum of an object is 6 kilogram meter second minus 1. If its velocity at that instant is 3 meters per second, what is the mass? So you know, using the same equation, we can find any of the three quantities. So again, we write the same equation. Momentum is mass into velocity. Since I have to find mass, I will rearrange the equation. Mass equals momentum divided by velocity. You can take the velocity to this side, but if you have the mass on this side, it will be difficult to calculate. So that's why I have completely rearranged it, taken the mass to the left hand side and divide P over V on the right hand side. So if I substitute the values, momentum is given to you as 6 kilogram meter per second. It's divided by the velocity 3 meters per second. So here the meter per second units will cancel off. 6 and 3, when you divide, it will be 2 kilogram. So that is the mass of the object. So I am sure, students, these are very direct and simple calculations, and you have understood the calculation and done it correctly. We will move on to the next question. The mass of an object is 60 kilogram. Now this is another topic. What is the weight? And here you can see they have given the gravitational acceleration as the approximate value 10 meters per second square. So you have to write the equation W equals mg. Make sure you put W because we are going to find weight, and G has to be used because we are going to use the gravitational acceleration. So then if we substitute the values, mass is 60 kilogram and gravitational acceleration is 10 meters per second square. Therefore, the weight of the object will be 600 Newton. Why? When the mass is in kilograms and acceleration is meters per second squared, the Newton is the unit for weight. The next one. If the gravitational acceleration on the moon is 1/6 that of the earth, it's less than the earth and it is 1/6 of that acceleration of the earth. What would be the weight of the above object on the moon? So here we have already calculated the weight. So since the gravitational acceleration is 1/6, you can directly divide the weight 600 Newton by 6 and give the value, or you can redo the calculation. So first I will redo the calculation. Here we can again write as W equals mg. M is the same, mass doesn't change, 60 kilogram, but the gravitational acceleration 10 meters per second squared, but it is 6 times less. You can write it this way, or you can multiply it as 1 over 6. So here if we simplify 6 and 60 get simplified, and we get the value as 600 Newton. That is the weight of the object on the moon. Or you can say, because the gravity of the moon is 1 over 6th of Earth, weight equals 600 into 1 over 6. So that will be 100 Newton. But here you have to make sure that you write this part again. Otherwise, it is easier to do the calculation again. Only thing, for the gravitational acceleration, we have to divide it by 6. So then we get the correct value for the weight. So students, this is again a very simple calculation. With that, we will move on to the next question. The weight of an object is 5 Newton. At a certain instance, its momentum is 6 kilogram meters per second. Due to a force applied in the direction opposite to the direction of motion. So here they are applying a force in the opposite direction of the movement of the object. The velocity of the object is decreased to 4 meters per second during 4 seconds. What is the force exerted on the object? So here initially the object is moving in this direction. Force is against that. So therefore there is deceleration. What is the deceleration? Initially the object is moving with a velocity of v. So that becomes 4 meters per second, and it takes 4 seconds for the deceleration to take place. Now we need to find the force that is exerted on the object. So students, you can see the weight of the object is given to us. We know I will write down the values again. Weight is given to us 5 Newton. We know the momentum, that is equal to mass into velocity, 6 kilogram meters per second. And also after the force is applied, we know that the velocity comes to 4 meters per second. But we don't know the initial velocity. So using these two values, we should be able to calculate the velocity. If we take this, weight is mass into gravitational acceleration, and momentum is mass into velocity. So there we can calculate the initial velocity. So before that, we can calculate the mass from weight. So here mass is equal to weight divided by gravitational acceleration. So 5 Newton divided by 10 meters per second squared. That will be 0.5 kilogram. That will be the mass of the object. Then if I calculate the velocity of the object, velocity is what? Momentum divided by the mass of the object. So, momentum is given to us 6 kilogram meters per second and the mass we have calculated 0.5 kilogram. Therefore, the velocity will be 12 meters per second. 6 divided by 0.5 will be 12 meters per second. So, now that we know velocity, so you all can see the velocity changes from 12 to 4 meters per second in 4 seconds. So, then we can calculate the acceleration. If I do the calculation here, acceleration equals change in velocity over time. So, that is going to be final velocity 4 minus initial velocity 12 divided by 4 seconds. So, that will give you a value minus 8 divided by 4, that is minus 2 meters per second square. We have discussed acceleration in detail in Unit 2, and you know when we get a minus acceleration, that means it is deceleration. So, what do we do now? We rewrite it as deceleration is equal to 2 meters per second square. So, here the answer will be deceleration equals 2 meters per second square. So, here we have already calculated the deceleration. We know the mass of the object. So, the force will be F equals ma. That is equal to mass is 0.5 kilogram and the acceleration is 2. So, therefore, the force will be 1 Newton. So, that is the answer for this question. So, what did we do? First, we used the values. The values given to us were weight 5 Newton and we knew that the momentum is this. Using that, first we calculated the mass, then we calculated velocity and then we used the equation for acceleration and deceleration 1 Newton. With that calculation, students, we have completed all the questions given in your textbook. I am sure you have a very good understanding by now as to how you are supposed to answer questions and to do calculations. But that will not be enough. We have to practice more. Therefore, we will discuss some additional questions. So, as I display the question, you can pause it and you can try the question on your own and then listen to the discussion to check whether you have done everything correctly. So, now we will move on to additional questions. Additional question 1. A balloon filled with air has been set up as shown in the diagram below using cellophane tape and the tube of a ballpoint pen. So, as you see the picture, you know it's related to the activity that we have done, related to the Newton's third law. Let us look at the questions. Write 2 observations when the thread tied around the mouth is loosened and the air is allowed to flow out of the balloon. indicate the direction in which the balloon moves and the direction in which the air flows out of the balloon using arrows. What is the Newton's law related to the above observation? Write two changes that could be made in the above setup so that the balloon will move faster. Write an instance similar to the above that you observe in your day-to-day life. Explain the motion of the above balloon. So, these are the questions related to the activity. I am sure you can answer them first and then you can listen to the discussion. I will move on to the discussion. The first question. Write two observations when the thread tied around the mouth is loosened and the air is allowed to flow out of the balloon. So, what do you see? You can see the air flowing out. Therefore, the balloon will move in the opposite direction, and also you can see that the size of the balloon will decrease. So, there are three observations. You can see the air flowing out of the mouth of the balloon moving in the opposite direction, and the size of the balloon decreasing. So, here they want you to write two observations when the thread tied around the mouth is loosened and the air is allowed to flow out of the balloon. So, here since they have said air is allowed to flow out of the balloon, we can't write that as the observation because it's already given in the question. So, we will write that the balloon moves in the opposite direction of the air flow. That is one observation you can see. They have asked for two observations. So, the second one we can say size of the balloon decreases. So, those are the two observations that we can write here. We can also say the air flows out, but here they have given that in the question already. Otherwise, we can write that as well. Next question. Indicate the direction in which the balloon moves and the direction in which air flows out of the balloon. So, as you know, air flows out in one direction and the balloon moves in the opposite direction. So, how do we show it here? We have to put an arrow this way. We have to write air flows out. You can't just draw the arrow and leave it. You have to say what happens there. And the arrow towards this side. And the arrow towards this side, balloon moves. Or we can say movement of the balloon. So, these are the two directions in which the motions take place or the observations occur. Air flows in this direction, balloon moves in the opposite direction. Now, the next question. What is the Newton's law related to the above observation? So, as we saw the diagram itself, we knew that it is related to the Newton's third law. And in the previous question, you marked the direction of the airflow, that is the action, and the movement of the balloon, that is the reaction. And they were in the opposite directions. So, here it has to be Newton's law. So, they have asked what is the Newton's law related to the above observation? Here they ask you to write the name of the Newton's law only. They haven't said state the Newton's law. So you don't have to write the law, you just have to write the name. Newton's third law of motion. Or you can even just say Newton's third law. You don't have to write the law. But if they said state the Newton's law related to the above observation, then we have to write the law. Next question. Write 2 changes that could be made in the above setup so that the balloon will move faster. So here we need to make sure the balloon moves faster. So here you can see in the diagram, the balloon had been tied with a thread, and if you remember in the question it said you loosen the thread. So if you loosen it a little bit, air flows out slowly. So that reaction also will be slow. The balloon will move slowly. So if we loosen the thread even more, the mouth will open bigger and there will be more air flowing out. So then the balloon will move faster. So by loosening the thread more, you can make the balloon to move faster. Here already they have used a twine thread. Normally in the activity we can use a metal wire. So that is a little more stiff. Then the movement will be somewhat slow. So to make it more faster, we can use a smoother metal wire, or here we can use a more smoother twine thread. By making it smooth, we can make the balloon to move faster. So here 2 changes that can be made to make the balloon move faster. So one change is that we can loosen the thread around the mouth more. So air can flow out faster and the balloon will move faster. And also we can use a more smoother twine thread. Second one, you can say use a more smooth twine thread so that the balloon will move faster. Another observation can be we can use a lighter balloon. If the rubber of the balloon is thick and if it's somewhat heavy, that also slows down the movement. So if we know that the balloon is heavy, then we can use a lighter balloon. But since they have asked only for 2 changes, these 2 changes can be written there. So these are the questions related to this setup. We have 2 more parts. We will go on to the next part. Write an instance similar to the above that you observe in your day-to-day life. So in everyday life, the observations related to Newton's third law of motion. So where you see an action and an opposite reaction. So immediately you remember many examples. We have discussed some of them: swimming, rowing a boat, shooting a rifle, even walking, you push the floor back, the flow pushes you forward. Jumping, again you exert a force on the ground and the ground pushes you up. Going on a swing, shooting a rifle, any of those examples can be given here. So they have asked only one instance similar to the above that you observe in your day-to-day life. So here we can just write as swimming, where you push the water back and the swimmer moves forward. So write an instance similar to the above that you observe in your day-to-day life. A person swimming. So that is an example for action and reaction. Explain the motion of the above balloon. So what happened there when we loosen the thread? The balloon pushes the air particles out. Therefore, the air particles push the balloon to the opposite direction. So that is what you have to write. So here action, balloon pushes the air particles out. So reaction, air particles push the balloon in the opposite direction. So here in the answer we have mentioned action and reaction, and also we have mentioned it happens in the opposite direction. So we have completely included the Newton's third law in this observation. So that is how you have to write the answer. Now we will move on to the next question. Second question, an airplane traveling with a constant velocity is shown in the diagram below. So here there is constant velocity. Will the magnitudes of L and W, here in the picture you can see W is a force acting downwards and L is a force that is acting upwards, and F2 is a force in this direction and F1 is a force opposite to that. So there are two sets of forces which are acting opposite to each other, W and L, F1 and F2. So here will the magnitudes of L and W be the same or different? Identify F1 and F2. Write the Newton's law related to the motion of the airplane. So quickly write down the answers, then we can discuss them. Will the magnitudes of L and W be the same or different? In the question, it said the airplane moves with constant velocity. And also, you know, normally it moves in the same altitude unless it's made to go down or up. So, if an object at motion is moving with constant velocity, that means there is no unbalanced force acting. So, therefore, the opposite forces W and L have to be same. F1 and F2 have to be same. They have to have equal magnitudes. So here the question is, will the magnitudes of L and W be the same? So the answer will be yes. So here we can say yes, the magnitudes of L and W are the same. This is to write the answer as a complete sentence, but for a question, when you write it for an exam, if the space provided is small, you can just give the answer as yes. Yes, they are same. Now, we will go on to the next part of the question. Identify F1 and F2. So here students, you can see the plane is facing that side. So that means F2 is the direction similar to the movement of the plane. So what happens there? The plane is trying to push through air particles. So plane is exerting a force on the air particles. But what does the air particles do? They try to push the plane back, or they exert a reaction against the movement of the plane. So F1 will be the force exerted by air particles against the movement of the plane, and F2 is the force exerted by the engine of the plane to move forward. So since they have asked identify F1 and F2, we will write the answers. F1, force exerted by the air particles against the movement of the plane. So what is F2? Force exerted by the engine of the plane. So this is for the movement of the plane. So those are the two forces we have identified them. So here, as you can see, L and W are forces acting in the opposite direction and they are equal in magnitudes. F1 and F2 are forces acting in opposite direction and they are equal in magnitude. So with that, we look at the next question. Write the Newton's law related to the motion of the airplane. If you look at all four forces as we discussed just now, they are all equal in magnitude and opposite in direction. So that means it is the Newton's third law that is related to the motion of the airplane. But here they have said write the Newton's law related to the motion of the plane. So here you can't just mention Newton's third law of motion. You have to write it down. If you want, you can write the name Newton's third law, but you have to write the law. Every action has equal and opposite reaction. If you want, you can specify that the action and the reaction are of equal magnitude and they are in the opposite direction. So, if you write it this way, it's fine. Every action has equal and opposite reaction. So, this is the Newton's third law. Since it says write, you have to write this. It's okay to write the name, but you have to write the law. If you don't write the law and only write the name, then it is not relevant to this question. Okay, students. With this, we will move on to the next question. Additional question 3. A setup prepared by a group of students to verify the Newton's law is shown in the diagram below. So, you can look at the diagram here. You can see there is a trolley and a rubber band is attached to it. As you see the picture, you can relate it to the activity given in your textbook. What do we do there? We stretch the rubber band while holding the trolley. Then we release the trolley and observe how it moves. And in the next step, we repeat the activity using 2 rubber bands. So, you know what happens in this activity. Questions: which one of the Newton's law is verified in the above? According to the law you stated in part 1 above, what can you infer from the activity above? Write 2 factors that need to be maintained constant in the above activity. Why do we need to pull the rubber band parallel to the trolley and to the same length? According to the above Newton's law, what is the force needed to accelerate a mass of 500 gram at a rate of 4 meters per second? So, here this is what we have to answer. First, you all answer the questions and then listen to the discussion. I will move on to the first part. Which one of the Newton's law is verified in the above? What do we do here? We use 1 rubber band, then we use 2 rubber bands. So, by increasing the number of rubber bands, what do? We increase the unbalanced force that is applied to the trolley and see how it accelerates. So, if it is the relationship between the unbalanced force applied and the acceleration of the object, that means it is the Newton's second law of motion. So, here they ask you which one of the Newton's law is verified in the above. So, how do we write the answer? We have to say Newton's second law of motion. So, the answer will be Newton's second law of motion. That is what is verified in this activity. According to the law you stated in part 1 above, what can you infer from the activity above? What do? We increase the force. What happens to the trolley? It accelerates more. So, from that we can infer that the acceleration increases with increase in applied unbalanced force. Or you can say the acceleration is directly proportional to the unbalanced force. So, we can write the answer as the acceleration increases when the applied force is increased. If you want, you can also include by increasing the number of rubber bands. So, I will write that within brackets. By increasing the number of rubber bands. So, when we increase the number of rubber bands, the force increases and the acceleration increases. Next part, write two factors that need to be maintained constant in the above activity. So, students, this is an activity related to the Newton's second law, that is F equals ma. We are looking at the relationship between unbalanced force and acceleration. So, we have to maintain the mass of the trolley or mass of the object, that is the trolley here, has to be constant. And also, we have to make sure that we have the same type of surface on which the trolley moves. So, those are two factors that need to be maintained constant. And also, when we stretch the rubber band, that will be the next question, that is also done in the same way. You have to stretch the rubber band from one end to the other, and you have to stretch it parallel to the trolley. So, don't write that answer to the question. We will write by saying mass of the trolley and the nature of the surface. These two have to be maintained constant. The next question, why do we need to pull the rubber band parallel to the trolley and to the same length? When we pull the rubber band parallel to the trolley, we always make sure that the trolley moves in the same direction. We are not pulling the rubber band upwards or downwards. That can change the motion of the trolley, because you all know both velocity, acceleration and also force, they are all vector quantities. They have a direction. So, here we maintain the direction constant. And also, when we pull it to the same length, we make sure that with each rubber band, we apply the same magnitude of force. One rubber band, one magnitude of force. And when we make it two rubber bands, it becomes the double the magnitude of force. So, that is why we have to pull it to the same length. So, here parallel direction of the applied force of the applied force is the same. And we say same length means same magnitude of force is applied by each rubber band. So, students, Here we stretch the rubber band from one end of the trolley to the other end of the trolley so that we apply the same magnitude of force with each rubber band. So when we use one rubber band, there is 1 unit of force. When we use 2 rubber bands, there will be 2 units of force. So now I will move on to the next question. According to the above Newton's law, what is the force needed to accelerate a mass of 500 gram at a rate of 4 meters per second? So here you can see the mass is given to you, that is 500 grams. And normally for Newton's law, we need the acceleration. Here they have said acceleration, but they say rate of 4 meters per second. So rate means rate of change of velocity. So here it means in 1 second, the velocity increases by 4 meters per second. So that means acceleration is going to be 4 meters per second divided by 1 second in a unit time. So that will be 4 meters per second square. So when they give you as at a rate, then the unit becomes 4 meters per second to show that the velocity increases by 4 meters per second every second. Now we can do the calculation. You know the equation F equals ma. So mass is given to you 500 grams. So that also has to be converted to kilograms. We divide it by 1000 kilogram and acceleration 4 meters per second square. So if we simplify that, 0.5 into 4 kilogram meter per second square. That is going to be 2. 0.5 into 4, 2, and kilogram meters per second squared becomes Newton. That is the force that is needed to accelerate the object. We'll move on to the next question. Additional question 4. Air flowing out of a rubber balloon is shown in the diagram below. I am sure you can remember this activity. We did this in the lab as well, and you got the observation clearly. You can see air coming out of the balloon. That is what is shown here, and you know what will happen to the balloon. So let us look at the questions. Copy the diagram in your answer sheet and draw the action and reaction. So immediately when you read those two words, action and reaction, you can relate it to the Newton's third law. Write the Newton's law demonstrated in the diagram above. So that is what you are going to write there. Write an instance related to the above law from your day-to-day life. So there again, you know a lot of examples. So I am sure you can quickly answer the questions and then you can listen to the discussion. I will move on to the first part. Copy the diagram in your answer sheet and draw the action and reaction. So the diagram is already given to you. You have already done it in your answer sheet. So how do we show the action? Action is the air flowing out of the balloon. And since the mouth is facing downwards, air will flow out from here. So that is the direction of the air flow. Air flowing out. And that is the action. Since they have asked you to draw the action and reaction, you have to mention this as the action. What will be the reaction? The balloon moving upwards. So here reaction, balloon moves upwards. So we have written both the words action and reaction. We have indicated the directions as well as we have mentioned what happens as the action and the reaction. So you have given a complete answer if you have written all these in your answer sheet. With that, we will move on to the next part. Write the Newton's law demonstrated in the diagram above. So by now, you know what they mean by what is the law and write the law. Here they have said write the Newton's law. So you know it is the third law and you know you have to write it here. Every action has equal but opposite reaction. Every action has equal and opposite reaction. That is how you write the answer. The third law. Write an instance related to the above law from your day-to-day life. As you can remember, students, we have discussed many examples and we have been writing different examples for different questions. Can you recollect all the examples? Swimming, walking, rowing, then two children pushing each other with their palms, even an aircraft moving upwards or aircraft flying towards a certain direction. All these have action and reaction. Shooting a rifle, the bullet moves forward and the rifle moves backwards. So since we have not written that as an example for any of the questions, I will write that here. When a bullet is fired, the gun moves backward. So that is the action and the reaction. So students, you were able to answer all these questions. That means you have understood the Newton's laws clearly. With that understanding, we will move on to the next question. Additional question 5. Diagram given below shows two different masses traveling with the same velocity. So here you can see this is a larger mass, 10 kilogram, moving with 5 meters per second velocity, and here there is a 2 kilogram mass moving with the same velocity. What are the two factors that affect the momentum of the body? Which one of the above masses has the highest momentum? What is the momentum of mass 2 kilogram? What can you conclude from the diagram above? These are the questions. So, you all can answer it and then listen to the answers. I will move on to the first part. What are the two factors that affect momentum? So, they want you to write both factors. When we say momentum, you remember the equation. Momentum equals mass into velocity. So, what are the two factors? Mass and velocity. So, we have to write the two factors, mass and velocity. Which one of the above masses has the highest momentum? So they want you to find the highest momentum. As we said now, momentum is what? Mass into velocity. So when mass increases, momentum increases. So obviously it has to be this object that has the highest momentum. So which one of the above masses has the highest momentum? We have to write it as 10 kilogram mass. So here we don't have to explain why, because they have just asked which one of the above masses. I'll go on to the next part. What is the momentum of mass 2 kilogram? So that is a direct calculation. You write the equation momentum equals mass into velocity, and here they have asked for the 2 kilogram mass, and the velocity is given to you 5 meters per second. So when we multiply, it will be 10 kilogram meter per second. That is the momentum of the object. What can you conclude from the diagram above? So here what are we observing? We use two different masses and we observe the effect of mass on momentum. So from these we can conclude when the mass increases, the momentum increases. So that is what you can conclude from the diagram above. So here I can write down the conclusion. When the mass of a moving object increases, the momentum increases. So that is the conclusion of this activity. I hope you all have understood and written the correct answers to all these questions. Now I will move on to the next question. Additional question 6. Write the name of the law that explains each of the instance given below. So you need to write the name of the law only. A gun is pushed backwards when a bullet is fired. So from this you can identify the law. Gun being pushed backward means it's the reaction and the bullet was fired forward, that is the action. Action and reaction means it has to be the Newton's third law. So here we only need to write the names. Newton's third law. You can say third law or third law of motion. A passenger standing in a bus is pushed backwards when it starts to move forward suddenly. We have discussed this example several times. The passenger is pushed backwards because the bus starts to move forward and the lower part of the body moves with the bus, but the upper part of the body is still at rest. Therefore, the passenger is pushed backwards. That is related to the Newton's first law of motion. So here we have to write the answer as Newton's first law. Then the third one, when forces of equal magnitude is applied on objects of different mass, the object with the higher mass accelerates slowly and the object with the lesser mass accelerates faster. So from this example, you can see that when the mass increases, acceleration decreases. And when the mass decreases, acceleration increases. That means acceleration is inversely proportional to mass. What law gives that relationship? It is the Newton's second law. F equals ma. So here we have to write the answer as Newton's second law. Okay, students. With that question, we have come to the end of additional questions. And now we have come to the end of the discussion on your 4th unit of your grade 10 science textbook. That is Newton's laws of motion. I am sure you have a very good understanding of the 3 laws, all the examples and activities related to the laws, the calculations done based on the laws. Then we discussed another topic, mass and weight, momentum, and we did calculations based on that. So you should be very familiar with all the equations and the calculations. But as I always say, that is not sufficient. You have to go through the lesson again and again and try and practice more and more questions, so that you will have a very good understanding of all the theory of the lesson, as well as you will be able to answer all different types of questions.